So you should already be familiar with sine, cosine, and tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent side. And the reciprocal of those functions actually have names. And the reciprocal of sine x, which is 1 over sine x, is CSC x, or cosecant x. And the reciprocal of cosine x, or 1 over cosine of x, is SEC x, or secant of x. And the reciprocal of tan x, or 1 over tan x, is equal to COT x, or cotangent of x. And since cotangent of x is just 1 over tan x, and tangent of x is equal to sine of x over cosine of x, we can also rewrite this as cosine of x over sine of x. Now let's do some examples for each function. And if you don't know how to solve these problems, like if we pretend secant was cosine instead of 5 pi over 6, if you don't know how to do that, then I would recommend go watching our video on the unit circle, because it explains how to do these types of problems, but with sine instead of the reciprocals. So if we have secant of 5 pi over 6, secant is a reciprocal of cosine. So we would need to write 1 over cosine of the value, which is 5 pi over 6. And cosine of 5 pi over 6 is negative square root of 3 over 2. So we would write that at the bottom. And then we multiply both sides by 2 to get rid of this fraction. So 2 over negative square root of 3. And that's our final answer for secant of 5 pi over 6. And now let's do cosecant of pi over 3. Cosecant is a reciprocal of sine, so we would need to write 1 over sine and then pi over 3. And sine of pi over 3 is square root of 3 over 2, so let's write that at the bottom. And this is pretty similar to last problem, except it's not negative, and we need to multiply both sides by 2 to get rid of the fraction. And this is equal to 2 over square root of 3. Now let's do cotangent of 2 pi over 3. Now you might think you would just do 1 over tangent of 2 pi over 3, and you can do that, but a faster way is to just do cosine over sine. Because as we said in the beginning, since a regular tangent is sine over cosine, 1 over that would just be flipped. So cosine over sine is equivalent to cotangent. So for this one, we would do cosine of 2 pi over 3 over sine 2 pi over 3. And cosine of 2 pi over 3 is negative 1/2. And sine of 2 pi over 3 is square root of 3 over 2. And for this one, we can multiply both sides of the fraction by 2 to get rid of the fractions. And we get negative 1 over square root of 3. And now we've done examples for each reciprocal trigonometric functions. And for all of these, you could technically multiply both sides of the fraction by square root of 3 to get rid of the square root on the bottom. But in this video, we're not going to be focusing on how to do that. And now, if we were given sine of x equals 3 over 5, and we need to find cosecant, secant, and cotangent of x, we shouldn't do anything with the unit circle or anything with the reciprocals. But first, we should draw a triangle and label one of the angles as x, and then label the sides accordingly. Since sine of x is opposite over hypotenuse, 3 will be the opposite side, and the hypotenuse will be 5, given by the fraction. And then we can use the Pythagorean theorem to find out the missing side right here. So you can just do that yourself, but the missing side is 4. And now we can figure out secant of x, cosecant of x, and cotangent of x. And we can use similar logic as we did with cotangent of x. We already said cotangent of x, since tangent of x is sine over cosine, cotangent will be cosine over sine. And since sine of x is opposite over hypotenuse, cosecant of x will be hypotenuse over the opposite side. So instead of 3 over 5, it will be 5 over 3 for cosecant of x. And here, cosine of x will be 4 over 5 because that's the adjacent side over the hypotenuse. And then we can take the reciprocal of 4 over 5, which is secant of x, and we get 5 over 4. So secant of x will be the hypotenuse over the adjacent side. And cotangent of x, again, as the reciprocal of tangent of x, which is opposite over adjacent. So cotangent of x will be adjacent over the opposite side. So that'll be 4 over 3. And that's one trick. So if you're given sine of x equals 3 over 5, something like this, you can draw a triangle and label all the sides, and then use the trick I just described to find secant of x, cosecant of x, and cotangent of x. Now let's get into some practice problems. If you think you know how to do this one, then pause the video and try it. But this problem asks to simplify cotangent of x times tangent of x. And first, let's rewrite both of these as cosine of x over sine of x times sine of x over cosine of x. You should already know that these are what these two are equivalent to. So now let's rewrite this as one big fraction because we can. Cosine of x times sine of x over sine of x times cosine of x. And we can notice that cosine of x cancels out cosine of x, and sine of x cancels out sine of x. And if we cancel out everything, we just get 1 over 1, which is equal to 1. So cotangent of x times tangent of x is equal to 1, which makes sense because if we multiply the reciprocal by the original thing, then you're always going to get 1. Now let's do another practice problem. If you think you know how to do this one, then pause the video and do it. This problem asks to find cosecant of x, secant of x, and cotangent of x, given that cosine of x equals 2 over 3, and x is in between 3 pi over 2 and 2 pi. Now, you may think we can use the trick that I described earlier by drawing a triangle, and you're half right, but if you notice here, x is in between 3 pi over 2 and 2 pi, which means that on a unit circle, this triangle would be in the 4th quadrant. So let's say the triangle was like this. Then, this side would have a negative value, the opposite side of the angle. Now, we can just draw the two sides that we already given, 2 and 3. So 2 here and 3 here. And they're not going to be negative because on a unit circle, these values will not be negative. However, the opposite side will be negative. So we have to watch out for that. Now, this missing side, you can do the Pythagorean theorem yourself, but it's going to be square root of 5 and 2 and 3. And since this has to be negative, this will be negative. And now, let's do all of these identities. Cosecant of x, since it's the reciprocal of sine of x, and sine of x is opposite over hypotenuse, this will be hypotenuse over the opposite side. So cosecant of x is equal to 3 over square root of 5 negative. And secant of x, we can just take the reciprocal of cosine of x, and we already have it. It's 2 over 3. So it's just 3 over 2. And cotangent of x is going to be the reciprocal of tangent of x, and tangent of x is opposite over adjacent. So cotangent of x will be adjacent over the opposite side, which is cotangent of x is equal to 2 over square root of 5 negative. And there. We did draw a triangle like the trick I described earlier, but since we're given the x value and they're within this specific range, we have to visualize it on the unit circle and make the sides negative accordingly, because remember, on the unit circle, values can be negative. So Everything that I explained in this video and all the problems that I went through should teach you everything that you need to know about reciprocal trigonometric functions, or cosecant of x, secant of x, and cotangent of x. If you learned something from this video, or if you enjoyed it, then please consider liking or subscribing.